Now, what does this term truth apt mean? Does anybody know what the word truth apt means?
Is that a statement that can be true or false? Like, for example, snow is white would be a truth apt statement because it can be true, snow is white, or it can be false that snow is white.
Correct. What would be an example of a statement that isn't truth apt?
Love is a rose.
That's a truth apt statement.
Is it?
Yeah. It's either true that love is a rose or it's false that love is a rose.
Go do your homework.
Correct. A command. A command is certainly not a truth apt statement. What are some other types of non-truth apt statements?
Is this statement true?
That's a question, so it's not truth apt. Questions are not truth apt. Commands are not truth apt. There's one other type that doesn't take a truth value. That's not one of these two things. So this is what makes a statement truth apt, is these two things. So what's another statement that doesn't fit these two?
Lamp.
Lamp. Just stating a noun. I guess that's not truth apt.
Hello, CoolDoG.
Anybody else?
Hey there, CoolDoG.
Pardon?
Hey there, CoolDoG.
Correct. Like just an introduction or just yeah, something like that.
Maybe something that is subjective, like I think you look beautiful.
See, that is truth apt because it's either true that you think that or it's false that you think that.
What if I just say you look beautiful?
That could be you look beautiful. Yeah, you're making a claim that it's true that you look beautiful.
Okay.
Why is a command not truth apt?
Because it doesn't. A command isn't really something that. So it's true that you're giving someone a command, but the command itself, the statement, go do your homework, right? That's not something that's either true or false, right? It's just what somebody wants you to do. It's not like true like the snow is white or you look nice in that outfit today. It's, depending on your theory of moral statements may be truth apt. I know some people don't believe that, but some people do. And so in that case, you should do your homework would be a truth apt statement because that should statement could either be true or false.
I have an additional one, maybe.
Yeah, sure.
This statement is false.
That is a truth apt statement.
But it's a paradox. I'm not a paradox, but it's a contradiction. Because it's a contradiction, it would not fit not both.
We're going to talk about that. That is a false statement.
Contradictions are false. Right?
Okay.
Contradictions are false. They take a truth value. The
That's
paradox is that it seems like that this statement would be both. And in more advanced logic, which will be the next series, we can actually start dealing with where we can get rid of this second condition here. But yeah, the other type of non-truth apt statement is exclamations, like, oh shit, I bumped my toe, for example. That is a non-truth apt statement. Oh shit, right? An exclamation. But again, for the purposes of our logic, right, we only need this to happen and we only care about truth apt statements, so either true or false or not both. All right. So let me clear this. Can I clear? Where's my clear button? Oh, I'll just refresh the page. Okay. So, how do I get rid of this? Okay, good. Okay, so let's take some typical statements that we have. So we're going to learn the different operators. Let me make this in black. We're going to learn the different types of operators. And so in logic, we have several different operators. I guess because we're using PLBot, we have more. So the cardinal operators are and, we have or, we have if, comma then, we have if and only if, sometimes called IFF. And then we have not. And then finally we have, for PLBot's purposes, we have the exclusive or, the exclusive or statement. So these correspond roughly to what we mean in English. So an example of an and statement will be, I have apples and a basket, for example. This is an and statement. And this is a truth app statement, right? Namely, it's either true that I have apples and a basket, or it's not true that I have apples and a basket. And we tell this by the and here, right? That's what makes it an and statement. So this means that I have both the apples and a basket, right? Pretty simple statement, just means and. And we symbolize and statements with, I guess for PLBot it's different, but there's several different ways that you could, there's several different ways that you can symbolize it. Most people use a V. Get out of here. Most people use a V. Other people, I think PLBot uses this. And these are the only really two ways that I've seen it really symbolized. Okay, get out of here. So these are the only two ways that I've seen it symbolized. So if we were to translate this statement into logic, what we do is we look at the operator, so we know it's an and statement, and then we look to see what is connecting these two operators, right? Here we have apples, right? And we have the basket. So why don't we just call the apples A? We'll call this A, right? And then we'll use our V, right? Sorry, not V. Sorry, I fucked up. Sorry. Pardon me. It's not V. That's or. I got confused. The way that you symbolize and is typically either a dot or the ampersand. Sorry, my bad. I got confused. I was thinking ahead.
In the bot, isn't it like a caret? It's like the.
It can also be this. These are the three. Yeah, these three. The ampersand and the caret work for the bot.
Okay.
You can use either. So when we're trying to translate into our logical language, I have apples and a basket. We make apples be A, right? We make our basket be B. Oh, sorry. Let me make it aligned so it looks all right. We make our basket B, and then we connect them with our operator for and. So we would write here A and B. Right. And so that's how translations work. They can get more complicated and we'll do more examples, but this is the general gist of how we do translations. Any questions so far? Okay. So let's go through the other operators. So or is kind of tricky. So when I say, let's do an example. You have either a hot dog or a veggie burger, or I don't know, or pasta. Let's do it that way. So you have either a hot dog or pasta. Okay, so what do you think the word or here means?
Well, since you mentioned there was an exclusive or, and this is not the exclusive or, then it can't be exclusive, can it? It has to be somehow inclusive. So maybe it means you can have a hot dog or pasta, or both a hot dog and pasta.
Correct. So what I'm asking here is, what makes this true? Oh God, I hate this thing. I don't know why it does that. I keep hitting a button and it doesn't. I think T. Just go away. Just go away. Okay, whatever. What makes this true? We'll power through that. So that's my question. What makes this true? What makes this statement true? Well, in one sense, what would make this true is I have a hot dog, right? What the hell? Am I holding control or something? Whatever. So I either have the hot dog, right? or I have the pasta, right? Or I have pasta, sorry, a little bit disordered, pasta. Or I have both the hot dog. Why does it do this? My God. We might have to switch to Word. Yeah, I'm going to switch to Word, whatever. Okay. So again, we have, would have been nice. So we have the and, which is equal to the ampersand or the caret. We have or, which we're talking about now, which is equal to a, it's a V or this is what the bot uses. And so we have the phrase, you have either a hot dog or pasta. Now, what makes this statement true is going to be either you have the hot dog, you have the pasta, or you have both hot dog and pasta. This is what's called inclusive or. Okay, it's inclusive, right? It's inclusive because of this both hot dog and pasta statement. So whenever we speak about logic, right? Oh, can you see my, yeah, okay, good. Whenever we're talking about an or statement in logic, okay, whenever we're talking about an or statement, we include both of the parts of it. So if we were to translate this into logic, if we were to translate this, we would write it as H, and then we could use this symbol or P, where H is the hot dog and P is the pasta. Questions about the inclusive or?
I have a question.
Sure.
So when someone like makes a coffee for you and they ask you, do you want milk or sugar? That's the same thing, right? They don't ask for specifically either you wanting milk or sugar. You could theoretically say yes to both, right?
Exactly, 100%. That's
Okay, great.
exactly the sense in which we're talking about the inclusive or.
Great, thank you.
Perfect.
Shouldn't the correct translation just be you have either do you like and or instead of just or? Like I think people also say like do you want this and or that? Like
That is also the inclusive or. Right. That's another way of saying it.
To speak about like a natural language, I guess, doesn't the word either maybe imply like an exclusive or?
It can. It can. So let's say that you say you can, so maybe the person here is saying, hey, what do you want for dinner? You can either have a hot dog or pasta and not both. And so this is what we would call an exclusive or XOR. An XOR, and I'm gonna have to look at PLBot here for a second. Let me see. Testing quizzes. So to do the exclusive or is this symbol, and you have to copy and paste it or know the alt code. No, he's so small.
And the word either can mean also as well. So you could say something like, I don't eat meat and my partner doesn't either.
That would be an and statement, actually.
Right, yeah. So I just mean to point out that
Yeah.
either isn't an exclusive or, either I think
Yes.
is
Okay.
and or.
And this is pointing out to the art of translation, right? These things don't map on directly, right? Because this either could mean exactly what Arco's saying. So that's going to be contextually dependent. Okay. Now, okay. The next, so this is the exclusive or. We'll talk about this guy later. He's kind of special. As well as the if then, if and only if, and XOR are kind of special terms for interesting reasons that we'll talk about. They're kind of interesting. So the next type of statement is if, comma, then. This one's going to be people use either an arrow. They usually use an arrow. We'll just use an arrow for now. So an if then statement is if you wash your car, then it will be clean. So the way we would translate this, here we have like a compound, right? If you wash your car. So you just have to pick one of the letters here to signify it. So we would say if W, then clean. Okay. Again, we're picking out the if then here. Let's call it red. We're picking out the if then here as our operator, and we're translating it here. Now, what would make this statement true?
If the car's clean.
So if the car is clean, okay. If the car is clean, correct. If the car is clean, this statement is true. If you wash your car and the car is clean would make this true. But what makes this statement false?
I think only the case of you washing your car and then it not being clean.
Right. If it's false that you wash the car, right? If it's false that you wash the car, right? And it's true that the car is clean, then I have lied to you with this if then statement. Sorry.
Wait, no,
Sorry,
no.
wrong way.
Yeah, you're wrong.
Wrong way. If it's true that I washed the car and the car isn't clean, right? If it's true that I washed my car and it's false that the car is clean, then I lied to you. Right? Okay. That is the if then statement, and we'll get into how to think about this more conceptually in a bit. The last one is if and only if.
Wait, before we go there, why
Sure.
why if both are false, why is the whole statement true?
If both are false. So you're looking at something which is this, where this is false and then this guy is false.
Yeah,
Well,
like with the example with the car wash, like if it's false that I wash the car, and it's false that the car is clean, why is the whole statement true?
oh, sorry, it just should be W. I got confused. Sorry. Yeah,
Well,
great question. Fantastic question. Fantastic question. If you wash your car, okay. So the way to think about this is this if then statement, right? This you washing your car, when it's false, right? This hasn't kicked. My if hasn't kicked, right? All I'm saying here is in all the worlds where you do wash your car, it has to be clean. If you don't wash your car, I'm not on the hook. It could be clean or not.
and from an intuitive, I guess, sense, like if you could have a dirty car and then someone comes to you and is like, if you wash your car, it'll be clean. That would be true.
Yeah.
Or could it be the case that you think it about this way, where you say, if you wash your car, then the car will be clean. I didn't wash the car, so it's not clean. So the condition, because the whole condition thing is still true. Like if you wash, then it will be clean, but you didn't wash, therefore it's just not clean.
So what you're pointing toward, okay, how about this way? If I come up to you, you have a dirty car. Your car is dirty right now, right? Let's say that I say, hey man, if you wash your car, then it'll be clean, right? And let's say the rain comes and it cleans off your car, right? Your car is clean, but you didn't wash it. What I said is still true, right? If you did wash your car, it would have been clean. Likewise, if you don't wash your car, right? I told you that if you washed it, it would be clean, and it's still not clean. Right? My if then hasn't kicked.
I see.
Okay. Again, if you don't agree, a lot of people have trouble with this. If you don't agree with me, that's fine. You'll see why we pick these operators in just a few minutes. But there's a specific reason for it in logic why we have these operators, because it exhausts the possibilities of truth values. But we'll see that in just a little bit. You might have been thinking of the if and only if statement. So if I were to write it this way, your car will be clean if and only if you wash it. Okay. So here we have to flip the letters, unfortunately, but it doesn't really matter for this one. So here we're saying, right, hey, your car will be clean if and only if you wash it. So in this instance, you didn't clean your car, right? It's false that you cleaned your car. It's false that your car is clean, and it's false that you washed it, right? So this statement would be true, right? Because I said that your car will only be clean, it will only be clean if you washed it, right? So this statement is true. If your car is clean, however, and you're a lazy butt like me, and you didn't wash it, right? If your car is clean and you didn't wash it, right? Then I lied to you with this statement. I mean, likewise, if it is false that your car is clean and it's true that you washed it, then I also lied. Right? Because I said it can only happen if and only if you wash it. And then, of course, the last case is going to be it's true that you cleaned it and it's true that you washed it. So this is the if and only if statement. Questions on this? It's if and only if. Okay.
So I think maybe it would be helpful to sort of translate each of these operations into logically equivalent statements that express it in some other way, so that we can really see what's being said.
Okay. If and all, so for and or, these statements are fundamental. So if we were to do an and, good question. So if we were to do an and statement, the way it would look would be, okay. So our P1 would be A, our P2 would be B, and then our conclusion would be A and B. With the or statement, you can do it two ways. You can say, hey, I have at least one, right? My conclusion is going to be A or B. Another one for this would be B. Conclusion would therefore be A or B. So that's for A and B. Now, when we're talking about if-then, it gets a little bit more complicated. But if-then actually means, if we were to say, hey, not A or B, this is equal to if A, then B, right? And then for if and only if, it's a little bit complicated, but if you wanted to see it, this is what if and only if looks like. This is what if and only if looks like. Is this guy. These two are the same. But we can get to that. It's a little bit more complicated. But this is what if and only if is.
So like basically, if you wash your car, then your car will be clean, and if your car is clean, then you have washed your car.
Correct, exactly. And both of those are true with if and only if. This guy's a little bit harder to conceptualize, but remember, we're gonna immediately get to truth tables after this, and it'll make things much more clear once we get to truth tables. I'm just going through all the operators.
And of course, you could write those if-then statements as or statements, right?
Well, yeah,
To break it all down to
which gets even more ridiculous, which would, that's why or and are fundamental, actually.
yeah.
Or B, or we can use this guy for the bot, and not B or A, not B or A. Yeah, you could write it that way. At any rate, The last operator, and then we're going to get to truth tables. The last operator that we're going to have is the not. The not is special. The not is very special, also fundamental. And he's a squiggly line like that, your tilde. So not is special because I can say, I do not have a basket. And I would simply symbolize this as not B, all right? What's the difference between the not and the other operators?
A not can stand alone.
Correct. It only needs one of our nouns, one of our properties. Correct. So what if I were to say, I do not have a basket and I don't have apples? How would I write this in logic? Well, now we're using parentheses. So this is saying, hey, I do not have a basket, right? So not B, and I don't have apples, not A. For example.
Could you just put not parentheses B and A?
I cannot. Common mistake. You cannot. These two are not the same at all in the slightest. Can somebody tell me what the difference between these two is?
I don't know what parentheses mean in this context.
Right, exactly. So the parentheses here is saying that this whole statement is false. So this statement is false. Let's use parentheses in another way. If I said, hey, if I have apples and a basket, if I have both of those, right, then I'm happy. Then I'm happy. What this is saying is this guy has to happen and then H happens. If A and B is true, then I know that H is true. Does that make sense to the parentheses question?
Sure. So for the above example of what's the difference, like A could be true in the second example, but the statement could be false because there is no B. Or like
right.
you could have B in that statement and the statement would be false. But then
correct.
But in the statement above, you need both not A and not B.
So this guy at the bottom, let me turn to black. Gotta go back into black, right? That'd be like AC/DC. So this is saying I don't have both apples and a basket.
Yeah, so you could have one of them.
Correct, exactly. I could have one of them. In this case, I can't have either of them. But in this case, I can still have one. I could either have the apples or I could have the basket. In fact, this statement is actually equal to not A or not B.
And this is inclusive or, right? Yeah, okay.
This would be the inclusive or. So I could still have not both. I could still have not both. I could still have not both. Right. But that's the difference. So not only applies to that. So let's do like a little example. Maybe like an ethical example. If this is like the euthanasia topic, if you have a severe mental illness, we'll say, or you have terminal cancer, then you can have access to assisted suicide, for example. This was like a debate topic that we had, right? This statement. So, yeah, this was like a debate topic. It was the first one I thought of. So how would we translate this into logic? Well, so let's pick out our if then, right? So this is our operator, right? This is our operator. So we know it's an if then statement. You can go ahead and put that on the board. Right? This is an if-then statement. But what goes on my left and my right? Well, here it's this, right? Either the severe mental illness or the terminal cancer, right? So I could say either the M happens or the cancer happens. And then if that or statement is true, then I get my assisted suicide. And so that's kind of how parentheses work. Does this make sense to people? How I translated this?
Yeah.
Question so far?
Could you define operator?
An operator is just these guys.
Okay.
It's just these statements. It's an operator because it connects nouns together. It connects these two together. See, the if then is connecting these two things together, namely the or statement. It's connecting this or statement in parentheses and the other atomic, you could call it, the other property. Good question. But I like to view in logic, you can view these guys as your verbs and then view your letters as your nouns. Okay. So let's hop over back to this, and I hope to God this works. I hope to God. So the way that we do this is we want to look at, so let's try to understand what's going on here. So when we have a statement, you know, A, not dollar sign, A and B, right? We have a statement here, A and B. Oh, that's gross, disgusting. So let's take this statement A and B, right? A and B. Now let's assume that I'm stupid, right? And I don't know what words mean. I don't know what A and B means. I want to know when this statement is true. For what conditions is this and statement true? For what truth do I have here? Like when different things are true. So what happens, for example, when A is true and B is true, for example? What happens when I have my apples and I have my basket, right? What happens in that case? Well, my and statement turns out to be true. True. Sorry, this should be. Sorry. So when both A and B are true, right? When both A and B are true here, when they're both true, then this statement is true, right? Now, when A is true and B is false, right? This statement is what?
False.
It would be false. Good. When A is false and B is true, this statement is what? False, right? And then when this is false and then this is false, then my statement is also false, right? Let me clean it up a little bit here.
This one is like the only one that I don't get, because if both are false with the conditional, then
This
it's
is
like
an
an if
and
then
statement.
one, but then it's true. Like it's the only thing that doesn't make sense to me
So
until
this is
today.
an and statement, right?
Yeah.
This is an and statement. So what I'm essentially saying with an and statement, right, is that I need both A and I need B to be true, right? I need both to be true. So here I'm doubly lying to you. I said I both have apples and a basket, and I don't have either of them. Right? I don't have either of these. So it's false. Right?
Yeah. No, yeah, like that's correct. It's just that
Okay.
I don't know how it intuitively how with the conditional could be true, but that it doesn't matter.
Yeah. I mean, if you don't believe me, then just You
No,
know,
I
there's
believe.
a big debate. This is the biggest debate in logic at the moment, is about the if-then statement.
Oh, really?
Yeah, it's the conditional's kind of screwy. There's entire books written about it. So you're onto something there.
So what you're confused about, right, is that if A implies B and A is false, then the statement A implies B is still true, right?
So
Even
let's
if
No, no,
Sorry.
no. It's when you have A implies B and both are false, but the whole statement is true, which I don't get why.
right, which is the same even if just A is false. Yeah.
So let's go through this. So this is if A is true, then B is true, right? When
Yeah.
A is true and B is true, so if I have apples, then I have a basket, right? So I have the apples and I have the basket, right? So I didn't lie to you. Here I lied to you, right? I told a lie because I said, hey, if I have apples, then I have a basket, right? I have the apples, but I don't have a basket. I freaking lied, right? So that's false. Here, right, I said, hey, if I had the apples, then I would have a basket. I don't have apples, but I have a basket, right? It's true. Why? Because if I did have the apples, I would still have the basket. I would have the basket, right? I just don't have the apples, so this doesn't kick, right? It doesn't apply. It doesn't kick.
Yeah, the
Same with
condition still follows.
Same with this guy, right? My A doesn't kick, right? It doesn't kick because my if then statement was only bound. It's like a contract, right? Think of it like a contract. If you sign this contract, then you can't disclose our corporate secrets, right? If you don't sign the contract, you could do either. You're no longer bound by the contract.
Ah, okay. I think that's a good example.
Make more sense?
So the rule only applies if A is true.
Yes, that's the only time it's false. The only time it's false is the only time it's going to be false is this guy, right?
Yeah, I
Where
think I get it.
this happens.
Yeah, so like basically how I think about it is that what follows from the condition, it still holds because when A was when A was like false, then B is not B is also false. So the condition still is still
Mhm.
true. That if it were to be true, then B would be true.
Mhm. Right.
Yeah, it's just a statement about what's going to happen if you do A.
Correct.
And you
So
can't demonstrate it to be false, yeah.
yeah, you can't.
So we could do a truth table. Let me see this. This clears. Good. Okay. So we could do a I'm going to post this in the event chat. We could do a truth table, an event, workshop, event. Where's my intro to logic? So I'm going to post in the event chat to let me see, pictures, Arthuria. I had it. So I'm going to post in event chat this image, which is going to be the Bible for this course. And if you look at the top part of this, you'll see all the different truth tables. I'll just go ahead and pull it up. I guess logic rules. Yeah. So if I pull this up, right, and we look here, you can see all of the different truth tables for these. Right? We just did draw. Okay, good. So we just did this guy, right? And we did the and statement, which would be this guy. But this will give you the truth tables for all of these. Yep. Now the thing about truth tables that we saw and what we did was, if you remember, how did I set this up? And this is the same all the time, right? I had my letters up here. Let's go for like A and B. right? I have my letters here, and I was able to write all of the different possible combinations for A and B, right? True, false, true, false. These are all the different possible combinations of true and false for A and B. Right? Does anybody disagree? But these are all the different possible combinations for A and B. And so this is what a truth table does. So like when I have the statement A or B, right? I can say, okay, and the way that I'm looking at this is I look, okay, decrease my size a little bit. I say, okay, what happens when A is true and B is true, right? This statement is, because it's an inclusive OR, is true. What happens when A is true and B is false? Well, I have at least one, so it's true. What happens when A is false and B is true? It's true. What happens when both are false? It's false, right? And so this is what a truth table does. So I'm just writing out all the possible combinations on my left side, and I'm seeing what happens with the operator. Now, what happens if I take that previous statement about the physician-assisted suicide, right? And I want to say, so what was it? It was either you have the mental illness, right? You have the cancer, or you have, and then you have the assisted suicide, right? Get my eraser out. So this statement we said was of the form either M is true or C is true. Okay, let me see. Okay. Or let me go ahead and do it this way. Or C is true, right? And then if those are true, then A is true. Okay, sorry, I messed it up. Darn. So M or C, right? And if those are true, then A is true. So here I no longer have all the possible combinations for these, right? So because this has 3 variables, right? Because this has 3 variables, this table doesn't work and we have to do a different pattern. I'll just show you the pattern. It doesn't change no matter what problem you're doing. The setup is always this.
There are more possibilities, right?
There are more possibilities. How many will there be?
8.
Correct. And so we can write them like this. It's the way to remember this is 4 in a row, 4 in a row, and then 2 in a row, 2 in a row. And then this is just alternating.
Or you can say 2 to the power of number of operators you're dealing with.
Correct. Number of operators? No, it's number of letters. It's the number, it's indexed to the number of letters. But yes, you're correct in your math there. Okay. So how do we go about evaluating this statement? So I'm interested in, when is this if-then statement true, right? It's an if-then statement, right? When is this guy true, right? So is this statement true when M is true, C is true, and A is true? Is this statement true when M is false, C is false, and A is false? Like, when is this statement true? This is what logic allows us to do, is it allows us to take this relatively complex statement, and I can tell you when it's possible for this statement to be true. So how do we go about evaluating this?
Wait, is this an inclusive OR?
It's an inclusive OR, yes.
Okay.
It is an inclusive OR.
So you'd probably look at the fact that it's an if-then statement first, and you'd say that you'd know that if-then statements can only be false if the antecedent is true, And the conclusion is false.
Yes,
So you would mark those down as
Yeah, you
false.
kind of brute forced your way into it, and it would be here, right? This is one, and then where's another one? I think that's the only one. Yeah, it's the only one. But you kind of brute forced it. You actually do it the exact opposite way because thinking in that way is hard, right? Because I have to keep in mind what my or statement means and what my if then statement means, right? Instead, we'll apply a trick and we're going to work inside the parentheses first. Okay? We're going to work inside the parentheses first and say, hey, when M is true and C is true, M or C is what?
True.
True. When M and C is true, this is the same guy. When M is true and C is false, it's what?
Still true.
It's still true, right? When M is true and C is false, it's what?
Still true.
Still true. Here it's still true for the same reasons, right? This is getting awkwardly terrible. Here, when FF, right? When FF, it's what? It's false, right?
False.
Here it's
Yeah.
false, yeah.
Now, let's make our life easy and just copy over the A table here. So here it's true. I'm just copying the A column underneath the A. False. Here it's true. Here it's false. Here it's true. And so while I admire Jacob's ability to keep all of this in his head at once, now all that I do is I compare this guy with this guy, right? So when the left side of my if then statement is true and the right side of my if then statement is true, right? It's what?
True.
It's true. When it's T and F, it's what?
False.
False. Good, Arco. When it's T and T, true.
True.
T and F, it's false.
False.
T and T, it's true. T and F, it's true. And then when it's false on the left side, it's always true.
Wait, T and F it's false, right?
Oh yeah,
Yeah.
you're right. You're right. You're right. I fucked up. Yeah, I got you. Sorry. Yeah, I fucked up. Yes. So T and F is false, right? And then here it's true, right? And then here it's true.
No, wait, here it's false as well.
Here
Oh
it's
no, wait, because the F is in front.
Yeah, when F is on the left, it's T. When F is on the
Okay.
left, it's true. So this is the truth table for this statement.
The one I find confusing is just the last one.
This guy.
I
Yeah.
have the same thing we were talking
I
about.
just, I mean, it just seems to me like we wouldn't know if it's true yet.
It seems counterintuitive that if the antecedent
Right.
is false, then it just seems.
The question, stop thinking about, this is a big problem. A lot of people take your position that this should be false. It's not an uncommon position.
Well, I'm not saying it should be false. It's just I don't understand why it is true.
I think it's more you can't demonstrate it to be false, so we just mark it as true.
Right. That's a way of thinking about it.
Well, I would just think about like the condition still follows. Like if it was true, then it would be true for the other side as well. But since it's false and the other one is false, it means that the condition is still just true. Like what would follow from the condition is still like correct.
Yeah, we're talking about whether the premise is valid, not whether it sounds right. So logically, it's still valid. It's just another argument would be whether it's actually sound or not.
It's more like is the operator true in this case? The
Right.
if then. I see.
Yeah.
I see.
Yeah, is the operator true? Again, I haven't lied to you yet. I have not lied to you. And if I haven't lied to you, then I've told the truth. I haven't lied to you. Right? You don't have a mental illness or you don't have terminal cancer. So then you don't have access to a physician-assisted suicide. I didn't lie to you. I just said that if you had one of these two, then you would have access to it. You don't have one of those two, so you don't have access to it. I didn't lie. I haven't lied yet.
I see.
Okay. And you can do, this is the same trick. Let's do a little bit more complicated one to prove concept here. We'll do it a little bit quickly. And then we'll move to testing entire arguments for validity. And then that will be it for the day. Let's do a complicated one. Yeah. Let me think. Let's do them with all the different operators just for funsies. So let's say that it isn't true Oh God, it's happening. Okay. Good. Just stop. Get the hell out of here. And why does it keep doing that? This software is great when it works, but then it just doesn't work. Okay. Do it again. Okay.
If you want, you could try using the bot. Would that be easier?
Yeah, let's do it with the bot. Yeah, let's do it with good point. Let's a good point to look at. Okay. So I'm gonna go into intro to logic chat. And I'm going to do the bot command, which is pl check. And then I'm going to enter into a premise. I'm going to say, it isn't true that A and B is true, or that, let's do it this way. This is going to make look like a very complicated statement.
Your screen froze for me.
Oh, well, I'm not typing on it, so I'm.
Oh.
I'm a little confused why we have MCA and then in the parentheses on the other side it's A and B. Are
Yeah,
A, M, and C? Is like A and B, M, and C here?
Yeah, you would have to change it. You would have to change it. So this would be A, this would be B,
Okay.
and this would be C.
And then C. Okay.
Is your thing not working, dude?
Me?
Oh no, the bot's not permitted in channel. Okay, I'm just gonna go ahead and post it into bot spam. Bot commands.
Can I ask? I'm new to this. Did you guys cover informal logic prior to this?
No, we're not.
Oh, okay.
Why is it not working? The bot's not working.
Wait 1 second, I'll have a look.
Yeah, bot's not working. Anyway. I need help with the bot.
It's not working in general, or it's not working in the text
It's
channel?
not working in bot commands or tests.
That's strange. Okay, that's awkward.
Okay, yeah, whatever. It's okay. We can proceed this way. And C is true. And then I wrote, well, now on my end it's working. Maybe just when I pick colors, it doesn't like it. So if you can do this problem, then you can do any problem. Okay, let's look at this guy.
Oh God.
Big scary statement, right?
If this is exclusive, if and only if.
This is an if and only if statement.
Okay.
Could you read it before
Yeah.
you start off?
So if A then C isn't true, if and only if A or B is true and B is true.
Wait, can you read it one more time?
If A then C is false, if and only if A or B is true and B is true.
Okay.
So then
It's a nonsense statement, but here we're using all the operators.
So in this case, you let me know if this is like the wrong strategy,
Yeah.
but I guess what I would do is similar to what we did in the last one, which is figure out the truth of all the parentheses and
Correct.
then do the operators around it.
Correct. You work inside out. We work inside out. So we're going to tackle this guy first, and then we're going to tackle this guy first. Then we're going to tackle this guy second, and we're going to tackle this guy second. And then finally, the major operator is third. Notice how these two sides are connected by this if and only if statement, right?
Yeah.
So we need to resolve the first two sides first. We can't use Jacob's method here and just think our way through it. It's just too much garbage, right? This is so much garbage, right? Not even I can do this in my head. Like, it's impossible.
Well, Jacob has like truth is beauty, so he can look
Yeah,
at
I
the
mean, this
equation
statement
and
is
know.
ugly to me, therefore
Not
not true.
Okay, right. So let's look at it. So let's do if A then C first, right? What are we looking at? We're looking at A here, right? And C, right? So A is true and C is true. So this statement is true, right? Then we're looking at the next one. If A is true and C is false, it's what? False,
False.
right? If A is true and C is true, it's true. TF, so false, right? And then because A is here, I know that the last four are going to be true because A is false. So I don't even
Wait,
have to
sorry.
think
On the third one, you said it sounded like you said if
Oh.
A is true and B is true, but A
Sorry,
is true
A
and
is
B
true
is
and C is
false.
true. Sorry, A is true and C is true, right? I'm looking at
Okay.
my bad. Yeah, my bad. My bad
No
on
worries.
that. Yeah. Sorry, I did misspeak here. Okay. So now we get to engage with the not operator, right? If we wanted to, or we can go into the other side. It depends on where you want to do. Yeah, bad argument. Thanks. Thanks, Lee Gunner, for doing that. I'll show what the bot outputs afterwards. So here, right, let's go ahead and work inside out, right? The next most inside thing I can find is this or statement, right? This guy, right? So let's go ahead and do the or statement, right? So now I'm looking at the columns for A and B. So like I'll be looking at this and I'll be looking at this, right? And go down the line. So then when A is true and B is true, A or B is true. When both are true, it's true, right? TF, so true. TF, so true. FT is true. FT is also true. FF and FF, these are the only cases where this is false, right? Now, again, you can tackle what you want, but now let's go ahead and keep working on the right side. Let's keep working on the right side. So now I have all the truth values, this guy here, right? These are all the truth values for this or statement. Okay? So now I will be comparing this guy and then this guy together. These two is what I'll be comparing together. Okay. So I say, okay, A and B is true and then B is true. So this statement would be what?
True.
True. B is true and A or B is true, so true. B is false and A or B is true, so it's what?
False.
True. False, because it's an and, right?
Oh, okay.
It's an and statement. Now we're looking at the and statement. So then F and T is false, T and T is true, T and T is true, and then these two are FF. Okay, good. So now, let's not confuse people. So now, right, this guy is my left side, right? Left side is here, is this guy, right? This is the left side of my thingy-maboggy, right? I still don't have the right side yet, right? What do I have left to do? Well, I have to do with the not, right? Because this whole thing here is negated. All of these on the left side is negated. And so all I do when I have a not is I switch the truth value. So I do this.
False, true, false, true,
Yeah,
false,
you
false,
just-
false, false.
Yeah, right. Exactly. And so now this here becomes my left side. Oh
And
man.
so now would we just do the if and only if operation with those two columns?
Yes, exactly. That's all you do. So now I just compare these two together using my if and only if operator. And so I do FT, so that's what?
False.
False. TT is what? True.
True.
FF is true, right? Because when they're both the same for an if and only if, it's true. When they're different, it's false. So that would be false. This would be false. And then this would be true. And then this would be true. And so so what did we just create? right? What did we just create? Well, I can now tell you, hey, if it's true that you have apples, and it's true that and it's false that you have, if it's true that you have apples, and it's false that you have a basket, and it's true that you have a car, right? This statement is true. This whole statement is true with these truth values for A, B, and C.
Big brain.
All right. We can do anything right now.
Now,
can you feel the power?
Yeah, the power. So
It's
now
over
let's
9,000.
Yeah, okay. So then the last thing that so this is how truth tables work. All truth tables work this way. You can beat PLBot using only this method. So let's take, I'm going to be in bot commands, PL check, and I'm going to do a simple proposition. If P, then Q, P is true, ergo Q is true. Okay. Misplaced symbol.
Oh, because
man.
the conclusion, yeah. Is that
Yeah, I posted, that was user error right there. I did it again, damn it.
Where is this? Where is that?
I'm in bot commands. So let's look at the output of PLBot. So PLBot says, right, PLBot says, I'm giving it, this is my input, right? This is P1, right? This is my P1, this is my P2, and then this is my conclusion, right? And look what he does. He makes a truth table for me, right? Just how you would do. And the way that you would do this with a normal truth table is you would just make separate columns for each of the premises. The way that you test for validity is if whenever the premises are true together, when the premises are true together, is the conclusion true? Okay? If this case happens, we're good. Okay? If, for some twist of fate, this guy was false, right? If this guy was false, right? This would be an invalid argument. This would be a counterexample.
So it's basically the if-then one.
Yes. This is modus ponens. This is a counterexample and makes it invalid. Let's take up a more complicated example. I'll show you invalidity. PL check. If P, then Q. It isn't true that Q and P are true together. And so then if I were to say that P is false, okay. Okay, let's take a more complicated example. This should work. Yes, okay, more complicated example, right? So in this example, I have two lines that are of interest, right? And in both these cases, right, in both these cases, it turns out that my conclusion is true. So this is valid. This is good. This is valid. Now, if I had a case, let's do a case where that doesn't happen. So let's say that if P, then Q, not P, ergo not Q. Deductively invalid. Okay. So let's take an example of this argument here, right? This is saying, hey, if P is true, then Q is true. P isn't true, therefore Q isn't true. This argument, and Lee did a nice job with this bot because it highlights it for me. But we see in this example, right, we have a case where the premises are true together and the conclusion is false. So this is invalid. This is bad mojo. You don't want this. This is terrible. So that's what makes an invalid argument. When you have premises that are true together, all of them are true together, and the conclusion is false. That's what invalidity means. Questions?
Yeah, I have a question. So if you don't have that scenario, it will be just valid. You're just looking for that scenario, right?
Yes. So I have an interesting example that I think Lee ran into it on his test. I'm going to put it into PLBot here. I saved it because when we do proofs, it threw me for a loop. This is P, if and only if Q, to make it true. Okay, so we have, and then if and only if not Q, and then parenthesis, not parenthesis, not P. Okay. Okay, so here we have this guy. Let's look at this guy. This argument is valid. Again, it's saying P is true. P is true. Okay, P if and only if Q is true, if and only if not Q is true. Therefore, not P has to be true. So when we look at this guy, right, there's never a case where the premises are true together. There's never a case where the premises are true together, right? This is valid. This is good. It's valid. The situation only kicks. The situation only kicks when the premises are true together and the conclusion is false. When I can't do that, when there are no cases where the premises are true together, it is valid.
Right. Is this valid though also because the second premise, like, yeah, I guess if you acknowledge the first premise, if you have P, then the second premise is a contradiction?
It's not a contradiction.
Or it's a, wouldn't it be? Because, okay, if you have P, then you have Q, and then you have Q or not Q.
Yeah, sure.
I mean, Q if and only if.
This premise is true when P is false and Q is true. It's true.
Right. I mean, I think that it is true. Just asking. I guess that's another way to do it. Anyway, never mind. I'll shut up.
I mean, we will.
There is a contradiction because it's P and not P.
Yeah, I mean that's the conclusion though. The conclusion's different.
But yeah, if there's a contradiction, then you can conclude anything. So this is
good. Yes. So let's show that. So in a contradiction, right? The standard contradiction is it's simply P and not P, ergo Z, for example. Let me make sure this is right. So this is a contradiction here. So this is a contradiction. Again, that's always false, but note, the reason why this is true is because I can't write a counterexample like this. There is no point where the premises are true. So I do not have the counterexample, so it is valid. This is valid. Now, going back to this guy, it says that it is vacuously valid and it begs the question. Vacuous validity is like this guy, where there is no, again, see, it says vacuously valid. So this is vacuously valid because there is not a situation where the premises are true together. You see, like in all of our other examples, like this guy, for example, the premises are true together, right? Premises here are true together in at least one place, right? But in this guy, right, we don't see that case to ever happen, right? So it is vacuously valid. There's nothing really there for it to grapple onto. It also begs the question, and this is what Jacob was talking about. It begs the question because you can derive the conclusion from just this premise because all of the truth values are the same. All of the truth values are the same, and you do not need this premise at all. That's why it begs the question, is when you can derive the conclusion from only one of the premises. That's what makes it beg the question. Okay, questions?
Can you just just quickly repeat why it begs the question? Just quickly.
It begs the question because, and we will do this in a later session because this is a very interesting proof to show how you can derive this. But because this premise has the same exact truth values as my conclusion, right? I can derive this conclusion from this premise alone. I do not need this premise at all.
So whenever you have, whenever all the truth values or all the logical truth values for one of your premises is exactly the same as your conclusion, then it begs the question.
Correct. Because, like, begging the question, the classical example of begging the question is going to be something like this. A is true, B or C is true, D and G is true, therefore A is true. So I'm going to go ahead and put this into PL check. So when we look at this guy, right, see, look how long it gets because we had so many variables, right? This is why you only do, you really only do truth tables with 3. You don't usually go above 3 because it looks like this garbage. But if you look, right, A is true, B or C is true, D and G is true, therefore A is true, right? My conclusion is in my premises, right? And you see that, it's the same, right? It's the same with all of them, right? Every time they match in every case.
Would you define begging a question as deriving the conclusion from one premise and having superfluous premises, or
Correct. You have to have superfluous premises. Yes.
okay.
So it would not be begging the question, but we can debate this. You could debate this. So if I did this, and I don't know how Lee has it, how he's got it set up. I think we talked about this a lot actually. How I think that this does not question beg. But if we look at this argument, right? For example, this is a bad example. But you see, just because I can derive the conclusion from only one premise, right? This is not begging the question because I don't have superfluous premises, right? My premise is true here and my conclusion is true here, so it's valid. I don't have a counterexample.
So isn't the begging the question thing when you have a premise that's the same as the conclusion, like logically? So it doesn't have to be in the same form, but as long as it's logically equivalent, then it's begging the question.
Let me see what the bot. Yes, that would be. Let me see what the bot does for this guy. A and B. I did A and B, and then I put C there, and then I put parentheses. B is true. Some would argue this is begging the question. Okay, this guy actually begs the question, which is interesting. So this guy begs the question. Yeah. Huh. Yeah, so this is where I get confused with what begging the question actually means. Because here...
This one has superfluous premises. That's why.
Yeah, I don't need this guy to derive it. But I think begging the question... I don't know, Lee. If Lee's in the chat, how did you program this to detect beg the
So
question?
it's changed over the time as we argue about it, basically. So currently, because in all instances of premise 1 being true, the conclusion is also true. That's basically what it is. So either in that case, or if like none of the scenarios were true, then it would also be begging the question. Basically, you can't show an instance where that first premise is true and the conclusion isn't true. Does that make sense?
Yeah, it makes sense to me. But I mean, begging the question is like, we could debate what that actually means to infinity.
So basically, if that premise is true, yeah, then the conclusion is true. That's currently how it is. That's subject to change, of course. That's currently
Like how logic is subject to.
In case that B is true, then the conclusion is true. And I guess you can get B from the first statement.
Yeah.
Sorry, yeah.
B is contained within the and statement, right? Because when A and B is true, B is forced to be true because it's an and statement.
Okay. Yeah,
There was I just have one more question. There was one of the arguments it had vacuously deductively valid. What does that mean?
So this was the last thing that I was going to talk to you about. Maybe this guy. So this guy is vacuously valid when there is not a case where the premises are true together. There isn't a case where the premises are true together. So I can't do a test. Like, remember with this guy, right? The premises, here the premises are true together, right? And here the premises are true together, right?
Oh, so it's like, it just so happens it's valid because we don't have like the scenario where, okay.
Yeah, we don't have a place to test it to begin with.
Then why do we say it's valid? We could also just say it's false, right?
Because to be valid, you have to show this counterexample.
Okay, I see.
Counterexample. You have to be able to show where my premises are true together and my conclusion is false. You have to be able to show me that.
Yeah, I get it.
Now, there is the soundness versus validity distinction. A valid argument is, as we just described, there's never this case. A sound argument means that the premises are actually true together in real life. A sound argument is a valid argument where the premises are actually true in real life. So in this case, where we can't do our test, this is unsound. It is not sound, unsound. It is an unsound argument because the premises cannot be true together in real life. So valid, but unsound. Likewise, if we took our simple modus ponens, or not this guy, well, yeah, our simple modus ponens, right? If P then Q, P thus Q. If it turns out to be the case that P is false in real life, if it turns out to be the case that these are the only two premises that we care about, is these guys, right? If this turns out to be the case, then this would be a valid argument, but it is unsound because P is not true in real life. So that's the validity versus soundness distinction. We went through about a month's worth of introduction to logic material for a college class in about an hour and a half. So there's got to be some confusion or some questions about this stuff.
I think
I have
would
one
need
question.
to like do tests or exercises to find out where I'm confused.
Okay, I can upload to you. I will upload in event chat. Let me intro to logic. Let me find my homework that I actually assign my students for this, and we shall see. You can 120 homework. Yeah. Okay. Yeah, okay. So I'm going to upload to the event chat. Yeah, Trop, so there's an error with what Trop wrote in event chat. I just saw that, sorry. You need parentheses around it. Because so Trop wrote, good teaching thing. Trop wrote this. He said not A, B, or this. So Trop wrote this.
Huh?
Now, what's the problem with writing something like this is I do not know where this negation is ranging over. So I could interpret this as either if A isn't true, then not B if and only if B is true. Or it could be the case that I'm saying if not A is true, then the entire statement B if and only if B is true. Right? So you need parentheses. You should never have two operators like this without parentheses, ever. That's just the thing. It's a common error. But yeah, so you would need to have parentheses there somewhere to tell me what that is. I'm going to upload my homework that you can do, and I'll be happy to look over them for you. Let me see, 5120. This was done pretty rough and ready for when we transition to online. I usually don't do it this way. But this is the homework that I assign for truth tables. We're doing we're doing prop logic. Tropical. This is prop logic. Propositional logic simply unless you mean something else by prop logic. Yes. Very close to binary logic. Yes, absolutely. 100%. Yeah. Yeah, you could call this binary logic. Yeah.
Is there any difference?
I mean, the only was the best in class. Yeah. Oh yeah. So people who do circuit design, it's the same exact thing, but they use different symbols. And when you're designing a circuit, you can input in these when you're designing a circuit. So it's a little bit different. Here we're just looking at all the possible combinations. But when you're doing something else, you might be saying, okay, my A wire is always going to be charged, and I'm wondering only in these sorts of cases or something like that. And there's like a little bit of difference, but it's basically the same thing. They use different symbols though. But yeah, I posted the homework, and you can look over it. This is pretty rough and ready, I believe. Yeah. So it's got translations that you can do. It's got the truth tables that you can do. Yeah. And so if you can do all of those, you'll have a pretty firm understanding.